We have the lunch. I thought this conversation was going so well, we let it go a little more. We picked on you guys first. We're going to start over here. Oh, you're not ready? Oh, my goodness. Okay, I'll tell you what.
The tables have all moved. So.
Yeah, okay, I'll tell you what. We're going to have 5 minutes for you to pull it together, and then we're going to have the readouts. 5 minutes, guys.
And when you give your readouts, please stand. Otherwise, it's just to see if
Stand with the microphone. Okay, we're going to get started. We're going to give you guys a break. We're going to start in the middle. Okay. We're starting. Okay.
And start.
Okay. We're going to start here and go down and then around. So, okay.
All right. So hello again, Oliver Kennedy, University of Buffalo. So our table basically focused on the most important thing for sustainability: money. Everyone. Any project that wants to outlive its normal grant life needs continuous infusions of money, if nothing else, because if you're dealing with data style building blocks, storage is really expensive, and if you're dealing with software, well, dependencies and software bit rot, things break, you need to continuously maintain it just to keep it alive. So projects need to be designed so that there will be money coming from somewhere, and we started thinking about how this could potentially be done. One suggestion was using kind of a retail space in terms of infrastructure support, where you basically, was discussed during the panel, where you have kind of this model where domain scientists, the expectations in terms of funding are made clear up front. We also briefly mentioned educating domain researchers on actual costs. So for example, uploading to Amazon is really cheap, but if you want to actually get data out of Amazon, it becomes substantially more expensive. So we also looked at cases where the NSF might kind of better be able to fund projects more efficiently. For example, industry is capable of producing a lot of technologies that we might be able to benefit from. As was mentioned earlier, there's kind of a shift from science producing, researcher producing new technologies and then industry adopting them to kind of the other way around. Might make sense to start focusing on technologies, developing technologies that industry has no interest in, at least not initially. And that leads to more problems with sustainability because industry is not interested. But at the same time, this is where the NSF can really have the greatest impact. One random thought there was to have a reviewer for proposals from industry to basically point out places where industry has essentially already solved a problem and not necessarily critiquing the science of the proposal, just kind of identifying proposals that are done. And then kind of looking at redundancy, places where so we have a lot of projects that target essentially different communities with essentially the same functionality. How do we kind of merge those projects together? Who's responsible for this? We didn't really have a good solution there, but kind of merging, I think the example was DMZ models that have different, target different communities. How do we kind of get them to work together to build standards, to build kind of common infrastructure that can be linking the federation, so to speak.
We're going to have to move on
that's
now. That's about 3 minutes. So actually the next table has, we're just going down the middle and then,
okay.
yep, and go on to the next one, Sue.
Yep.
Thank you. 2 minutes.
So I'm Sham Dwarknath from Lawrence Berkeley Lab. I feel like the same people are scribed, so we should start a support group. So we also thought about this in terms of basic economics, but maybe at a higher level in terms of like a business model, like what are our costs and what are possible opportunities? And looking forward, I mean, there are some really big costs that are involved. Who is going to be responsible for data is something that I think no one in this room really has a good way of answering, because no one wants to be responsible for the data, but they want to generate lots and lots of data. But also, if you have lots of data and you have lots of people accessing data, then the access paradigms are important, and then cybersecurity becomes a huge issue. And we're not really, as DIBS, hooked into how to deal with the cybersecurity issues that are there. And maybe we're not the best suited as researchers to think about this. Maybe this is something where industry is the best partner for this, and we need to do a better job of bringing them in so that when that issue comes up, they're able to kind of think in the paradigms that they need to solve our problems. And then, there is associated with that the cost to deal with specialty data. So you may not have, human subject data, but you may have medical data as part of something for sensors or something else, and privacy and all the other associated costs with that are necessary to deal with. And that's something where maybe NSF can deal with building a structure for that so that those costs can be absorbed into the entire program versus each individual program trying to deal with it on a entity by entity basis. Now, the other side to that is there's lots of opportunities, I think, that we have. Some of the things that we talked about is that as academics, we are much more free to play around with data than industry is, and so they can use us as the test bed for their technologies, but also this is somewhat of the fear of losing out and monetizing on that, capitalizing on that, making them know that by investing in us, they get an opportunity to be involved in projects that they may not think about, and then that may become the next spark. And if they want to be part of that, they need to give us money. There's also workforce development. I mean, the MATLAB model, right? Just put MATLAB in every university and everybody knows MATLAB. Put your product in every university and everybody knows that. And so when they go to get a job, they already know what they need to work effectively there. There is also probably a need for better cross-institutional buy-in. This is NSF, there's DOE, there's DOD, there's Europe, there's other agencies. How do we build this from just a small little system for just the people in this room to something that the world as a whole can move forward, hold data, share data, deal with the data, give access, and full fair possibilities there.
Good. Thank you. Next table.
Hi, Boris Glavich from IIT in Chicago. Our table was also mainly talking about reproducibility. So the idea was when we talked about some of the use cases that were up there for the data revolution. So the idea is when we run an analysis, how do we actually know that this analysis is producing a correct or reasonable result, right? So, and I mean, I know that this has been a topic that has been overemphasized many, many times, but we basically looked at this. There are two kind of challenges there, right? The technical challenges of how can I actually rerun an analysis on a different machine? What does it take? How much description or how much capture infrastructure do I need to be able to actually physically repeat it? And so that basically, the idea was essentially how much repeatability do you need, right? So yes, if I run some specialized code that uses vector instructions, then it will only run on machines that have this vector instructions, right? So, but maybe that's too much and I don't need it at that level. So the idea is essentially for the technical challenges, not just talking about how far can we go about reproducibility, but also what reproducibility level is actually needed. And that brought us to talk about the social challenges of that, right? So without any incentives, there will never be reproducibility, right? Because right now, if we think about this, right, so the tenure process means basically we are being evaluated based on funding and publications, right? So I'm not getting more publications if I make my research reproducible, right? So this is not right now not getting me much, right? So the question is like, how can we provide incentives to force people to make their research reproducible, right? So, and there are some efforts that go in this direction, for example, right? So, for example, Zigmod the Zigmod database conference had this for some time, this reproducibility challenge that you would get a mark on your paper that was reproducibility, right? So, but they're still not helping me with tenure right now, right? So, the question was also maybe that is kind of echoing a discussion from yesterday, that maybe NSF can help with that a little bit. Right now we have to submit all of our publications in our yearly report, so maybe we can submit also pointers to data sets, right? And there are some incentives that we have to do a certain level of reporting that doesn't add much effort for people, but at least, right, there's some incentive. So if I want to get the funding, then I actually have to produce like a minimal thing there. And then the last aspect that we talked about was like, if we're working with a domain scientist, they are also interested in reproducibility, right? So if they have a high quality data set that they're very careful about, they want to learn more about their data by running our analysis software, right? And then the question is, can they trust our analysis software? So then they provide us with a reproducibility challenge that we can tell them essentially, how do we know that the result is correct? And then they learn more about their data, right, which can help them in the data collection. So there might be like a feedback loop to figure out essentially end up how much reproducibility do you need. Yeah.
Thank you.
So Tim Nat, University of Memphis. We really had three themes here. The first was treating your project as a business and using that to consider alternative services. So you have to come up with what your value proposition is. And based on the experience around the table, don't wait until the end of your project to figure this out. Otherwise, you're going to have a slight bit of a challenge finding money. One of the groups started using cost sharing as a way to bridge gaps in funding. So your grant runs out, now you have a cost sharing with some service. You can bridge that gap until the next NSF or NIH grant comes in. Look into educational services, training services. And then also one of the projects here started exploring industry funding for the infrastructure support. So they're coming to a supercomputing center or coming to the experts, everybody in this room, looking for help on, I don't know, artificial intelligence, machine learning, whatever your domain is. The next theme is building communities. A number of the projects here are all open source, and we've had to focus a lot of effort on building that community so that your team or your project can then see wider acceptance around the country or around the world. And then the last theme was use your data infrastructure as your secret weapon. Right? If it's not sustainable now, leverage the data you have, leverage your expertise, continue your research, and then eventually that might be sustainable. So thank you.
Well done. Next, yep.
Okay, so Kate Brinson, Duke University again. So I got assigned this reporting task at the end of our discussion, so I'll be brief. And if I miss something, someone else can chime in. So one of the things we talked about at the beginning, inspired by the HDR slide that we're supposed to think towards, was how do we help the normal scientists benefit from HDR? So since computer scientists, I guess, aren't normal, then the rest of us are normal. Anyway, the concept there was to remove friction, to create transparencies. In finding data and being able to get it in useful form. That we shouldn't have to know where the data is or how it's formatted to be able to access it. So that's a sort of a big idea. We don't have the big solution for it, but that's a big challenge. And I think we would go far if we could start to address that. Another thing we discussed was generalization. How do we generalize our tools and our platforms when we don't really know what the destination is going to be? So we are, I think we do have to work with the model of growing things organically and then linking them once they grow, because we don't know what the future holds. And so we have to retain that flexibility. And another thing that was discussed that was how to seeking a way to abstract quantities so that it makes it easier to connect things across the different domains. So trying to think at a higher level, and that's sort of a challenge for all of us to do within our own domains as we build our systems. Forget anything? Okay.
Great. All right. Let's start in the back. Yep.
Hi, I'm Scott Yokel from Harvard again, and we focus a little bit on thinking about there's a lot of tools that are created, and we worried that when are we going to quit reinventing the wheel? Like, are we just creating these same sets of tools and there's slight variations with a different funding, with a different project? And so that led to some questions, like what tools are actually out there from projects that have been funded, right? And beyond that, like at what level of readiness, as we've talked about, what are the usability level of these tools? And then the other thing that was of concern is that a lot of times the new shiny is seen differently in the light of a proposal than like phase 2 and 3 and 4 of a larger tool set or larger tool chain. And that those are the types of projects that would really move us to this harnessing the data revolution, and not just creating new tools, right, but making much more mature tools, more robust. So then we talked about the possibility of some type of centralized repo where you would, it's mostly just indexing and checking in that these apps exist and they have some type of metadata. And we talked about the difference between the types of things you could have in this versus what you would already have in like a GitHub, right? So in GitHub you have, you know, the maintainability and the popularity and some of that other tools, but you don't have, there's no defined language of the way in which you would tag your tool, right? The tool is for this data resource or this type of thing. There's no, you know, you can't see a lot of different tools in one pane of glass, right? You have to go deep dive into each one of them to understand that. So like having a higher level view of tools would be very, very useful. We also talked about there's a bit of a disconnect in the accolades for software tools that are in practice versus what we would normally think about in academia. In academia, we look at things normally as the currency of publications and funding and that kind of stuff, as opposed to the download, the usage, the following of the tool, the community around that, and those things are really important for sustainability in the future. So that there needs to be some understanding that that's kind of the currency when it comes to tools around data. And then that also there tends to be a disconnect or there's a missing connection where in other agencies and other places that have funded large-scale tools and data repositories, it would be nice to have some success stories for these really large projects to come in and explain the process of how they would go through that process.
Great. Next table.
Okay, Vasantha from Penn State. So our discussion sort of focused around this larger challenge of, taking these ideas that are coming out of these individual projects and making them useful in the context of harnessing the data revolution. So, and we had some discussion around generalizability of tools across different domains, and we concluded that it's going to be too challenging if we tried to do this across all of science. And so perhaps a way to look at it is an ecosystem of ecosystems. So smaller, sort of disciplinary focused groups, hierarchically organized, self-organized into larger and larger groups. So let's say, material scientists form a group and so on. And so to make that workable in practice, then maybe we need sort of disciplinary focused metadata, community-driven metadata and ontologies and process descriptions. So instead of thinking in terms of one big tool being reusable, perhaps it's useful to think about some components of these larger tools, larger efforts being reusable. Maybe the tool that I built is not the best for everything that it does. It's maybe some pieces of what it does. And so if you want that to be reusable, then you have to have input-output descriptions of what it does in some standardized form so that people can, other software can find it and compose it into useful artifacts. So that was just going beyond sort of metadata, but also process descriptions, input-output descriptions. And then we had some discussion around outreach and training, which is a theme that has come up before. In order for any kind of effort to be sustainable, we need a community to sustain it. So one way to sustain things is by sustainability through interoperability and reuse, which is the first set of topics. The second is sustainability through community that's ready to use and make use of it, which requires outreach to the scientific domains as well as training. And we talked briefly about potential ways to make this happen. RCN, which is kind of a glue grant that brings smaller groups to come together when they're working on complementary things. Supplements, and perhaps an untapped mechanism for the DIPS efforts is the big data hubs and spokes, which also has at a high level this goal of translational science. And so particularly if you're interested around organizing some community, maybe a big data spoke might be among.
Thank you. And last but not least,
Jerry Ryder from Duke University. So I'll try to be brief since I'm holding us up from lunch. Our group talked about a lot of the same issues that we've heard. In particular, we started talking about some of the challenges of going from where we are now to realizing the HDR. Talked about the challenges of integrating heterogeneous data, making systems interoperable. Who's going to own the data? Who's going to curate the data? Where are all these DIBS tools that are being created going to go? So these are all questions that we thought were important to address going to this bridging. And we came upon a few ideas that we thought might be useful for helping to make that bridge. And one of them is sort of looking at the DIBS work. We feel that a lot of